The opinions expressed are those of the participants and do not necessarily reflect the official positions of the sponsors, advertisers, or presenters. Advertising does not imply endorsement by the sponsors and presenters.
Hey guys, and welcome back to this week's episode of the Lighting Controls Podcast. We have another fantastic guest for you today, and someone who's actually been on the show before. But before we jump into any of that, I just want to take a minute to remind everyone that today's episode is presented by the LCA, the Lighting Controls Association, and it's also financially supported by NAILD, the National Association of Innovative Lighting Distributors. And if you haven't been to lightingcontrolspodcast.com yet, what are you waiting for? That's where all the cool stuff is. We have our merch, we have our shirts, we have our coffee mugs, we have hats. You can find our news feed. Make sure you subscribe to the podcast. Find us on all the social media channels. And now over to Webster to tell you about our amazing sponsor for this episode.
Thanks, Ron. Yeah, so today we are really grateful to our sponsor, McWong International. You can find them mcwonginc.com to find out more about them, but they're a really great IoT platform for customized solutions for lighting controls, but also a special shout out to them for winning the Bright Star Award from LEDs Magazine. Their True Blue Bluetooth mesh fixture controller with long-range antenna recently was awarded the Bright Star Award, and I think it's really valuable and important thing to note because it's really impressive that what they've been able to do with this device. They're really leading the charge when it comes to wireless IoT application technology, and I highly recommend you check them out, mcwonginc.com, and see what the fuss is all about. Additionally, if you can't get enough lighting controls information, you should check out NYC Controlled, the conference that's coming up. We're going to have a link in the description. I will be speaking at this conference. It's a one-day event in November 14th on a Tuesday. You should check it out if you, again, just want to see more about lighting controls. They're going to have a great showing. But now to the episode. So today we've got a special guest, Steve Mesh. Steve Mesh, you've been here before a couple of times, but just for those who haven't listened to the episodes before, do you mind just giving us a quick breakdown on who you are and what you do?
Absolutely. Thank you very much, guys, for inviting me back. I'm mostly a lighting designer. I've actually done many different things in the industry since 1980, so now you could do some quick math and see how old I am. Been doing this for a long time, mostly in the role of an independent lighting design consultant. I've also worked for a few major legacy manufacturers and also did a stint as the resident lighting expert at the Pacific Energy Center run by Pacific Gas and Electric. So I've approached educating people about lighting and controls from all sorts of different viewpoints, which is actually pretty interesting. As really each one of them has informed every other thing that I've done. So I really have a very well-rounded, take on a lot of different things. I'm not just going in there with one thing going like this. I've seen it from different viewpoints. So it helps me to try to explain stuff to people too. So been doing that for a long time.
Well, thank you so much. Yeah, well, thank you so much. I mean, it's great to always have you on here and always just great to chat with you, whether on the podcast or off the podcast. And so, one of the things that you and I were talking about at one point was emergency controls, especially because you recently published an article through Lighting Controls Association on the very subject. And because there's so much going on right now with the new UL requirements and standards that are being revised as we speak, and we've had some really interesting conversations with people involved in those groups as it is. It would be great to get you back on here to talk more about emergency lighting controls because it seems to be a growing hot topic right now. And so maybe some of our listeners still aren't aware or familiar or even knowledgeable of what is going on when it comes to lighting controls. So, let's at least start from the basics of emergency lighting, for people who have zero experience when it comes to that. What is the original intent of emergency lighting controls?
Yeah, that's a great starting point. So I'm going to just be really upfront about this and tell you that the whole impetus for me to take this on as something to learn more about so I can explain it better to people is the interview that you guys did with Steve Terry. who was a super duper expert in this, right? And that
Absolutely.
was really quite amazing. And I thought, wow. So the basic functions, as Steve has said, and I'm slightly pilfering from Steve, but it made perfect sense. So I'm just gonna reiterate what he says,
He's
which
a
is
great
that
resource for sure.
he's the guy. So basically, basic functions are to sense an emergency situation, meaning predominantly power loss, although there are others.
Hmm.
Transfer from utility power to emergency power to
Hmm.
illuminate emergency fixtures, and then to bypass normal lighting controls,
Hmm.
meaning
Right.
that
So it's
emergency fixture should come on. Right.
right. So the sum of it is the emergency fixtures should ignore everything and go to the emergency level, whatever that may
Right.
be. In
Right.
historical cases, it would be full output. Um,
Right.
and basically, because utility power gets severed, you're forcing it over to a new circuit that is dedicated to emergency.
Right. That's great. That's a great summary. Yeah.
So yeah,
Right. So
that I
that's
think
pretty much it in a nutshell. Right.
right. And so what is the big fuss? Why do we have to belabor so much? Doesn't it sounds very simple to me? Just okay, switch it over.
It can be simple, but the reason that it's complex is because normal lighting equipment and controls keep changing and evolving. That's the reason. So all of
Hmm.
these new regulations are in response to all of that change in the industry. And so, it's this is something that I spent literally 6 months working on last year. That's how long it took me to dive into this. And I should say, by the way, and hopefully this might be a comfort to some people who are watching this, that I'm a lighting designer, but I am not a licensed electrical engineer. I
Hmm.
don't even play one on TV. I'm not an electrical engineer. So as such, that means I don't stamp drawings the way certain colleagues do. And I'm going to mention a colleague. I assume that's okay with you guys.
That's okay.
My
Yeah.
incredibly esteemed colleague, Rick Miller, who I've worked with for a
Mhm.
long time now, helped me go through this process. Rick is somebody who actually did a 3-hour workshop on emergency lighting at Light Fair several years ago. That was a great presentation. And I realized that because of all these recent changes for UL 924 and NFPA 101, that we would both be interested in really getting into much more nuts and bolts about this. Even Rick, who signs off on drawings for this is still new for him too. So we thought, hey, we're going to go through this with a really fine-tooth comb, really try to understand this very carefully. And it's a lot of confusing stuff. So I wanted to make sure I really was clear about it. And since I don't sign off on life safety stuff the way Rick does,
Mhm.
I thought, boy, if I'm going to take on the task of trying to explain this to people, I have to be completely clear about my understanding of this stuff, right? Because it's serious,
Right.
because it's life safety. Yeah.
Yeah.
Yep.
Yeah.
Well, and so yeah, I mean, I think that that's a really important thing to identify is that we do have a lot of materials out there from, years ago that have been sort of the standard for reference material when doing design work. But at the same time, you bring up another interesting point about stamping entities versus non-stamping. So professionals versus non-professionals, people who can say, yes, this is approved and my license is on the line if it goes wrong, and people who
Right.
cannot do that. And so
Mhm.
as somebody who's not a professional, you can't be the final say on drawings, but in a lot of cases, we do see that there's a lot of finger pointing when it comes to who owns the emergency scope, because it's like, well, you own lighting controls, so you own the emergency.
Right.
But I'm not a professional. I can't do emergency, and so it
Right.
seems as though there really still isn't some consensus about who's responsible for that, even more so than lighting controls, let alone.
Right. And I have I have a philosophical viewpoint about that, which is that historically, in my experience at least, which we might argue is relatively limited, but in my experience, I think at least historically, a lot of quote unquote lighting designers have shied away from taking any responsibility or ownership for anything that's electrical or whatever, right? To the
Hmm.
point where even way in the past, they would, my colleagues and myself would even say, hey, whatever controls, like that's the electrical engineer. But if
Hmm.
you think about it, it's kind of silly because, first of all, why shouldn't, I know a lot about controls, I may not be the absolute world's expert. I know a lot about it. Why shouldn't why shouldn't I participate in that? And also, by
Hmm.
the way, that means if I develop some expertise in that, uh, that may be helpful for the project team because maybe I end up with a lot of expertise that adds to that. Maybe the electrical engineer knows the stuff I do. Maybe they don't. Who knows? I'm not even going to worry about it. I'm just going to develop some expertise about it. That'll add to the project team. I just simply won't be the person to stamp the drawings because I haven't gone through the
Hmm.
electrical engineering process, right? But why not
Yeah.
have that expertise to add to the process? And I it's so it's getting so complex now that I just feel like, wow, I'd rather kind of understand it than not, whether I'm signing off on the life safety drawings or not. Because if something happens during the design process, I don't want to find that something happens that messes up my designs because of
Mhm.
some, seemingly, minor little thing, which completely, completely derails something. That just seems
Hmm.
kind of silly
Yeah.
to. But it means that I had to do a really deep dive in this to understand it because the recent
Yep.
changes really have some major implications. Yeah. Yeah.
Yeah, and it does really
Right.
seem like it's right now, especially with emergency and controls, it really does seem like it feels to me like it needs to be more of a team effort, right? The electrical
Yeah.
engineer has their part, the controls designer has their part, but they know the intent, they know the fixtures. A lot of these electrical engineers, they see directly controlled luminaire and they get confused. I mean, there's a lot to that, and we really
It's a
need
lot
to
to it.
work
Yeah.
as a team. Yeah, so what is the, I guess,
Yeah.
for our listeners, if they're approaching a project, whether they're on a design side or they're on the engineering side, what is the best way to sort of have those conversations early to establish, hey, let's work together on this?
Well, that what you just said, I think, is the best thing to do is to have those conversations early, and that would be true whether it's emergency lighting or just normal controls, because
Hmm.
now
Yes.
that's IoT, right? If you're using a network
Yep.
system, hey, you're dealing with IoT. If you're not dealing with IT professionals on a project up front, something's going to be a problem later on for sure, right? But yeah, because depending on what the method is, either the emergency power source is a generator or central battery inverter or whatever. These are major, building-wide systems that you can't not have these conversations as a team. You just can't. It's serious business. You got to know what's there. If it's a retrofit situation, that's arguably probably even more complicated, right? But whatever it is, whether it's new construction or a retrofit, it's a lot of different parts and pieces. Yeah.
Well, and so
Once you
let's
once you
talk
get
about
through it,
those.
it's not actually that complicated, but it's a lot of stuff to work through to get to that point. Yeah.
Mhm. Totally. No, and so let's talk a bit about parts and pieces because when it comes down to emergency lighting controls, what are the primary components of the emergency elements that we're dealing with when we're setting up a lighting control system that's going to have that override?
Well, I guess the first question is what's the emergency power source? Because if it's
Hmm.
an integral battery in a fixture and the switchover happens in the fixture, that's pretty simple and straightforward. Well, even
Sure.
before that, let's just back up in case this is a brand new topic for anybody listening.
Yep.
If you have separate unit equipment like bug eyes or what have you, then it has no impact on your normal architectural lighting
Mhm.
system anyway, because it's a completely separate system. So, of course, that's the easiest thing to do, right?
And so
And
just
those have
to
batteries.
clarify what a bug eye is, in case anybody's not familiar with that term. Floodlights.
Right,
Yeah, they're
right.
those ugly
Yep,
boxes on the wall with two lights or one light that flood the space when an emergency happens.
right. And
And
the irony, by the way, sorry, go ahead.
no. Go ahead.
The irony with quote unquote bug eyes are that they're always located at the exit door or near the exit
Mhm.
door. they're always shining into the path of egress from the exit door, which means that from a lighting viewpoint, it means you're going to be blinded in a dark,
Hmm.
probably dark space as you're trying to get to the exit door. From a
Right.
lighting viewpoint, that's awful, right?
Sure.
And actually, when you think about it, it's hard to imagine that that ever achieves the actual lighting requirements for emergency egress.
Hmm. For
Really hard
sure.
to
No,
believe that, right?
there's a lot of debate about that for sure. But I think, that's
Sure.
one of many reasons why we've gone in the direction of using the normally operating lighting in the space as the
Hmm.
emergency lighting. And so
Right.
going away from bug eyes seems to be the trend right now. We don't like the
Hmm.
idea of using bug eyes anymore. And so we use the lighting that's already illuminating the space to be that emergency illumination. And so what you
Hmm.
were talking about was an integral inverter or battery pack that just switches the light on if the utility power disappears.
Right. And the transfer happens in the fixture. So it's
Hmm.
relatively simple, would automatically bypass any controls as a result, right? Because that's all downstream. But
Hmm.
you can also have a generator or a central battery inverter, and that's upstream. So that's different. Yeah. So now it's different methodology as to how to bypass the controls or now actually use the controls. Now it's getting a
Right.
little more complicated, right? Yeah.
Right. So yeah. So we're moving away from the fixture, and we might have a device between the fixture and the controller that
Mhm.
basically does what?
So the way the topology works is that if you have a generator or if you have a generator, you will have a UL1008 transfer switch, which is upstream. That's what people call
Hmm.
ATS, automatic transfer switch, right? Upstream to transfer between utility power and generator power. So
Hmm.
that will run through what used to be called emergency panels. It's now called normal/emergency panels. That means normal means that it's taking utility power. When the transfer
Hmm.
switch moves over, it's taking generator power, so emergency.
Hmm.
But that will be, circuited to particular fixtures. Let's say, for sake of argument, 10% of the fixtures in a space, right? Whereas
Sure.
the other ones will all run through the normal panel. Those will drop out in power loss situation, but those fixtures will just continue to be supplied. Now the wrinkle is what happens when you have controls associated with those fixtures,
Right.
because where are those in the topology? That's the issue, right?
For sure. And so, the most common situation that we see is that a breaker panel is dedicated as a normal emergency breaker panel, and that is feeding the branch circuits for everything emergency lighting wise. But
Mhm.
what are we powering the controls with? Are we powering the controls with emergency, or are we letting them die because the power loss has hit everything else?
Yeah, and that's getting complicated these days,
Right.
especially because of some of the recent changes to UL 924 and NFPA 101.
Right.
So,
And so
yeah, so
what are
there,
those
yeah.
changes?
So, so there's been some new terminology that has been adopted, such as directly controlled emergency luminaires, was directly in response to development of network lighting control systems
Mhm.
that now says, hey, we're acknowledging that this stuff exists in the field now. Yes, those controllers may be embedded per fixture. Now, what does that mean, right? Once that's right there, but you're getting power from some other source, like, whoa, we got the controls right in the fixture. It's not even out here somewhere. It's right there. Now what's happening, right?
Well, and so for the
So
sake of my colleagues' sanity, there have been so many people who have asked me about what a directly controlled luminaire is. Would you mind telling us what that is?
I do not mind. In fact, I'll read it to you. How do you like that?
That's great.
Let me just, yeah, yeah. I figured this, I thought there was a really good chance that this might come up.
I feel like I've had at least 4 emails recently asking me about
Yes,
this, and it
It's
just
not
seems to
even that
be
new,
yes,
though. I mean,
no,
it's
no,
that
it's
that
been in
right.
the UL
terminology has
standard.
Yeah, it has for
That's
a
right.
while.
It's not new. It's actually, I believe I got this all clear. This took a lot of research to really understand the whole history of this. I believe that this was new in 2014, and it was
Yep.
Sounds right.
revised in 2017, 2020, and now 2023. So I'll read you the latest. This is the actual verbiage. It says where emergency illumination is provided by one or more directly controlled emergency luminaires that, upon loss of normal power, respond to an external control input to establish the required emergency illumination level, such directly controlled emergency luminaires shall be listed for use in emergency systems. Luminaires that are energized to the required emergency illumination level by disconnection of their control input by a listed emergency lighting control device shall not be required to be listed for use in emergency systems. So are you guys still awake? Still awake after that?
I'm gonna summarize that for people because
Please
it is a
do.
lot.
It's a lot.
You're basically taking a massive Subway sandwich and you're trying to compress it. But
Hmm.
the concept here is that if a fixture has no control signal whatsoever, it should go to an emergency state, whatever that state has been decided to be. Historically, it's been full output. Nowadays, we're looking at more generous ways of illuminating spaces, so you're not blasting full output of your emergency fixtures. But it still has to be a decided upon level. It can't just be, okay, fine, set it to 50% and we're good. It has to be measurable and recreatable. But basically, that's in the absence of any control signal whatsoever, whether it's 0 to 10, dolly, DMX, et cetera, et cetera. Once that data is lost, it goes to that output. If it does not do that behavior, then it must be emergency listed. It must be tested to be able to take in a control signal under an emergency condition and behave accordingly. And so this is really the line in the sand was about 0 to 10 volt here, because 0 to 10
Yep.
volt by NEC must fail to full output because of the
Mhm.
way that it's set up. The drivers are set up. Whereas DMX and Dolly do not. That's not a part of the standard. It's not a requirement. It's sometimes referred to as hold last look, and is usually when you're dealing with like theatrical productions or something like that. That's where you most commonly find that, because it's like, oh, what happens if somebody trips over the DMX cable and it unplugs itself? But we're talking about life safety here, and you're not going to have your
Right.
theatrical fixtures being used for life safety. And
Well,
so,
that's not necessarily true.
all right, fine. I retract that statement. The majority of times you're not, but you're right.
That's fair.
There will be some crossover. But in the instance of an emergency condition, you want that to have precedence over any other condition.
So it should be said that that not only do the controls have to be listed, but the
Correct.
fixture also has to be listed, and that's
Correct.
what's
Yes.
getting. That's why this is getting
So
more
long-
complicated over time.
So long as that fixture is taking an input during an emergency event. If that fixture is not
Yes.
taking
Correct.
an input during an emergency event, then it does not
Yes.
need to be listed. And that was the
Right.
confusion early on, that people were pushing back and going, what the heck is this?
Yeah.
So I actually have a list that I should probably give you guys a quick list of this, and tell me if you guys completely concur with this. And in our research, our 6-month research project, this is the list that Rick and I came up with. And Rick, by the way, is probably one of the country's top dolly experts, so he's extraordinarily knowledgeable about many aspects of this. So besides being an electrical engineer, so the big distinction here is between, as you mentioned, Webster, whether things are happening because you have a control input or because you don't.
Right.
Whether you lose, whether you get the signal or you lose the signal. So if you have a loss of an external control signal, That could just be a loss of power because you might have a fixture with an EM driver, for example.
Right.
You could open the 0 to 10 circuit, right, with the UL924 relay. The UL924 relay will be listed, but the fixture doesn't have to be. Only that relay has to be. You can open a dolly network because the dolly can go to preset emergency scenes, right? But on the other hand, if you have something like DMX, where you have a pre-recorded emergency scene, and that's relying on the signal getting sent out among the dolly universe, that's different because it means you have to have that signal, which means that's right, DMX universe. Or for that matter,
Sorry,
a
you
signal
said
from...
dolly universe.
Sorry, a DMX. Right.
Yeah, no worries.
Right. A DMX loop. Or for that matter, a signal from some other system like a BMS system, because that means you're relying on a signal coming in, and therefore that fixture and anything in it is part of the emergency system as such.
Well, and I think that there's an interesting distinction here as well, because when you're looking at dolly versus DMX, you're looking at a streaming versus command-based format. With DMX, it's immediately apparent when the signal's lost. With dolly, it's not as immediately apparent. And so dolly, I would say, is the one that would be closer to what the emergency is talking about when it comes to commands and getting a control signal input for emergency. I'm not saying that it's not possible to set it up the way that DMX operates, but it's just that the way the protocols work are very different, and therefore DMX is much better set up to follow a non-listed fixture setup than dolly is.
Right.
So what this highlights to me, you guys should tell me what you think about this statement that I'm going to make. What this highlights to me is something that I figured we would touch on, and this is perfect time to do it. What it highlights to me is the increasing complexity of this because of the increasing complexity of the controls that we have available to us. Yeah. And because of that, it's no one's fault. It's just the stuff's we have more complex stuff that has all these great functions and features. But because of that, that's why the code language has changed, and it's getting a little complicated. Look, imagine it's hard enough for us to keep tabs on this, and we're experts in it. Think about an authority having jurisdiction, or even just a normal electrical engineer. It's hard, right? So I think what this highlights is, wow, like it's getting a little complicated. But what's the real serious concern is to make sure that somebody's going to sign off on it, because if they're not going to sign off on it, they might. What if you put in a DMX system and the authority having jurisdiction says, "Wait a minute, we're not okay with that." What does that mean? You got to throw out the DMX system you just paid a lot of money for,
right? Plus
the fixtures that that take that input. You're not going to want to do that, right? That's why you have to have those conversations up front. Yeah. Not only, especially with the whole team, and hopefully somebody is in contact up front with the AHJ, the authority having jurisdiction, and saying, hey, this is what we intend to do. If there's any issue with this here in this jurisdiction, please let us know, because then we won't use a DMX system. Maybe we'll use a dolly system, or we'll do something completely different. Yeah, like that could be, we could be talking about big money there. Yeah. Well, and but it's a lot of stuff to figure out,
Yes, totally. And on the topic of AHJs, and as it pertains to emergency lighting, it's not easy to bend the ear of an AHJ before documents are issued. So I don't know if you happen to have any recommendations for our listeners for how to get their attention.
That's a really tough one, because they have to deal with so many different things. This is just one of many. And we're specializing in just this one area. It's really tough. But what I would do, considering that I'm a lighting designer and not an electrical engineer, is I would absolutely want to do what you guys both mentioned up front, which is to engage with the team and say, guys, this is serious business. There have been some recent changes with this in recent years. We have to have this conversation up front. We just cannot not have that conversation. So actually, I'm curious, Ron, in your dealings with people, what have you heard in terms of this kind of thing from them?
Yeah, so we, coming in usually in the outside as an integrator, one of our first questions to everybody is usually, has that discussion happened, right? Because we find out often that usually it hasn't, right? The lighting designer maybe
Right.
didn't,
Because
or
it's
the
a tail
controls
that
designer
wags the
maybe
dog.
didn't engage. Right. Or they say, oh, the engineer's handling controls. And you go to the engineer and he's like, well, I didn't know there were DMX controlled lights. I didn't know anything about that. How do we handle this? And then, I've had occasions, unfortunately, where I've had to go back to the lighting designer and say, hey, these fixtures aren't listed for emergency use and they're DMX. So
Yep.
what do you want to do? Like, I found a couple alternates for you. You're the designer. You tell me, but like, here's a couple options. I just trying to help. So it can be a tough conversation. But like you said, the earlier you have it, the better off everybody is, because it can be very complicated. And I don't know about you guys, but I find myself having a lot of conversations with people differentiating between life safety and emergency, right? Or what I consider to be emergency from a control system, which is a fire alarm input, or a lot of, now there's so many different alarm types, or a lot of these schools and colleges have security like alarms that go off for intruders and things like that, right? So you're taking an
Right.
emergency contact versus a life safety scenario, and those can be
Right.
treated very differently in the controls as well. So how are you handling those conversations?
Right. And by the way, since you mentioned that, I'm really glad you mentioned that, because I might have forgotten to touch on that. It occurred to me during all of this just enormous deep dive that I did on this last year that normally I'll speak for myself, and you guys can chime in if you want, but I know that normally when I talk about emergency lighting with a vendor, or I'm talking about it in class, I'm really almost always talking about a power loss situation, as
Yep.
opposed to fire or security,
Yep.
possibly others, right? But certainly fire and security. And, the potential ramifications in terms of sequences of operation could be completely different. So for example, in a power loss situation, regardless of time of day, where it is, who knows, the point is to have lights on to illuminate the path of egress to emergency egress levels, which are different than normal egress levels, right? But still to illuminate the path of egress. In a security incident, I could imagine that we might want all the lights to turn off. It's completely the opposite, right? How do you affect that with the stuff you have, right? So that's getting even more complicated, right? So as an example, I can tell you that I use a particular system. I've used many different actual network lighting control systems in classes where people literally wire them in commission in the class, and they find out it's not actually rocket science. It's complicated, but it's not actually rocket science, because they do it themselves. Like, whoa, that's pretty cool. One system that I use actually has the ability to use one of the two contact closure inputs to send a signal out, or to get a signal in. Actually, that is designed so that it can take a signal from a fire alarm system. And I should mention something about that, by the way, that it's just one line in NFPA 101. And when I saw that, I was like, whoa, which basically says that if you have a new project and you have a fire alarm, the fire alarm has to be able to send a signal to the lighting controls to have them come on or off to the appropriate levels. That's a big deal, because that's tie-in between systems now. Well,
Right.
guess what? These network lighting control systems, these guys aren't stupid. They're incorporating that functionality. So they're like, okay, you bring that signal into contact closure 2, there you go, So, okay, it's a little complicated, not that complicated. The next question that I had, which I had an extensive conversation with the vendor, is, so what happens when you pull up the software and you say, okay, emergency? It actually says right in the software, is it a power loss? Is it a fire? Or is it a security incident? It turns out that there's no distinction between what the system does. And I didn't ask them at the time, and I should really go back and ask them. But I think that the reason that they wrote that into the latest software update, I have to keep updating all this equipment because they keep changing the software. That's fine, adds new functionality. But I think what they did, they put that in as a placeholder, thinking that maybe at some point in the future they'll say, hey, not only does it allow you to do one thing with it, but maybe it allows you to do two or three things. Maybe if you designate it as security, it'll do something completely different than if you get a signal from the fire alarm. Functionally, it makes perfect sense, right? But it's an additional wrinkle. But hey, I went to art school and I understand it. So trust me, it's not that complicated. Believe me.
But yeah, I mean, I think, one of the things to really point out when it comes to emergency controls components is a majority of them do operate off of very simple input command technology. We're very infrequently, if ever, are you going to see more than just contact closures or dry contact, which is essentially a electrical impulse that turns on and turns off, and based on its state will determine what the behavior is going to be. So, if the fire alarm activates and sends voltage down its contact closure signal, it'll then put the lighting control system into a panic state, essentially. And so, that's a very simple design in comparison to a lot of lighting controls technology nowadays.
Oh yeah, but the future. We won't go very far down that road, but I'll just tell you, because I had these conversations, this is really interesting what is theoretically possible in the future. For example, let's say you have a fire, and let's say you have a system where you got sensors all over the place, like maybe an LLLC system, and maybe those also have temperature sensors, or even smoke sensors. What if you had a big project, and in all the hallways, circulation areas, those sensors could figure out where, the fire was, or where the smoke was, or was not. That could potentially activate fixtures in such a way to redirect you away from where the actual fire was coming from. That's a little complicated, right? It turns out that UL has specifically declined to take that on right now because of the potential liability implications. And I've discussed it with UL. And when I first heard that, I was like, wow, this is getting complicated here. But it's when you think about the functionality, it's kind of cool, right? Because if you have those sensor technology, which is so small and inexpensive now in every fixture, you could theoretically do that. But think about the liability. So they're staying away from it from now. They're probably waiting for other things to mature. But going forward, just like this directly controlled emergency luminaire designation, it's like, oh, things are getting complicated. But if you want that functionality, then you have to be willing to deal with that increased complexity and learn it and understand it. And again, it's a little complicated. It's not that complicated, but what you can potentially do with it is really cool. But you really have to make sure that they're going to approve it.
Absolutely, and furthermore, going again, I feel my colleagues tapping on my shoulder and going, "Excuse me." When you have that much technology embedded into the fixture, who's responsible for that as a designer?
Well, that's part of the issue. That's why UL is staying away from that future scenario for now. They're acknowledging that it's possible. Anything's possible at this point. It's all just like just hire some 12-year-old to do the coding, right? But it's the liability issue. Yeah, but that's possible right now, right?
I think taking a telescope that can look into the future or something and peering into where the future could be, where we could be with technology. We do have the capability right now, and it may be that in the future people are going to look back and be like, why didn't they do this earlier?
Sure, of course.
And I think part of that, it is really kind of disappointing that so many jurisdictions, so many people are pushing back on it, because it's like, this isn't just like some cosmetic thing. This isn't just some glitzy idea that people have. This could save lives. Has the potential to. It also has the potential to harm or lose lives because of poor implementation. But I think one of the reasons why UL is saying no, but at the same time, it's like, why are we not studying this? Why are we not spending the time doing it?
Well, just as a kind of as an example of the possibilities, I've been in the Midwest a lot this year and last year doing a lot of classes and all sorts of other things. And I was in the middle of nowhere. Shouldn't really put it like that, but I was in the middle of farmland. I mean, I drove hundreds of miles through
So
cornfields, which
many
was
people who are going to
beautiful.
be so angry about that
And
statement.
I'm sure they will be. But it was beautiful. I drove literally hundreds of miles through cornfields. But once you get to a town, like, hey, they've got warehouses, they've got schools, they've got hospitals. There's stuff all over. Just because it's in the middle of the country doesn't mean there's nothing there. I stayed at a hotel, and I noticed across the street there was a whole series of electrical vehicle charging stations. I was literally in the middle of the country, and I thought, wow, they're not waiting for this. They had like
Hmm.
10 charging stations. I'm like, oh my God,
Right.
too bad I didn't rent an EV. They're not waiting, right? They're not. They're
Right.
not all waiting. Yeah,
No,
so
that's
it's
true. And
it's really it's the liability issue and whether or not the
yes.
AHJ, and that's a I don't know, that's a tough nut to crack, right? Because you're still
Mm,
ultimately relying on a particular person in that locale. It's
right.
Yeah, and
decentralized. Like I don't know how we crack that nut.
I know, and it's tough, right? Because it's more than just the AHJ. There's still too much finger pointing, right? I mean,
Right, of
now you
course.
get into, is it a controller within the fixture? Is it a centralized control system? There's just, right? Because you can't, if it's centralized and if it's done through like relays, maybe you don't have the ability to redirect based on right fixtures. Whereas if
Right,
it's a controller
absolutely.
within a fixture, you can easily turn X fixtures off. So
Right.
it's tough until we get to sort of one sort
It's
of
tough.
central idea and solution.
So,
Right.
it's funny since you said that, I have an interesting reaction to that. You guys tell me what you think. I think that could help make the case for more digital equipment because part of the issue is, once we go to digital stuff based on open standards, that's stuff that could potentially be part of the standards, which so far really is not,
Hmm.
you
Right.
know? Like analog 0 to 10 drivers, there's nothing in an analog 0 to 10 driver. We need other stuff automatically, right? Maybe if there was standardization for what happens in a separate, i- you know, add-on controller, maybe. But if the digital drivers were ubiquitous like they are in other places, that could be part of the open standard, right?
Well, I think that hits on
That's
a
hopeful.
drum that Ron and I beat regularly, which is standardizing
Yep.
of protocols and not having
Yeah,
this Wild West. And
right.
so maybe that is the roadblock right now, is the fact that because we can't standardize our systems, let alone the controls, then the controls will not be able to expand to a more advanced level until we get to a point where we can all agree, yes, this is the protocol, this is the behavior, this is
Yeah.
how lighting should behave.
Yep.
And, by the way, since we're talking about that, I'll tell you a funny story about something that happened during the 6 months in which Rick and I put all this material together. I live in a 45-story condo building in downtown Honolulu. And one day, while I was creating the PowerPoint for the emergency lighting webinar, the alarm went off.
Mm,
And that's the first time since I moved here that the alarm went off. And I'm like, oh man, the alarm went off. So, of course, I went down the stairs. I live on the 20th floor. I went down. You'd be amazed how tiring it is to walk down the stairs. It's pretty incredible. And I got downstairs and I got to the lobby. And of course, they have a fire alarm system, which means they're supposed to have tie into the network, to whatever lighting they have. They probably God knows, what they had. But what was interesting is, irrespective of the lighting, everything did what it was supposed to do. The elevator doors closed, the fire doors closed, and so forth. I got downstairs. I was the only one who went down the fire stairs. Nobody else went down the fire stairs. It turns out that it was a false alarm because of a restaurant down on the first floor. But what was interesting is that these guys, they even have like a PA. Everybody has a speaker in their unit, which is great, right? But there was a lot of confusion about what was going on
mm,
and whether or not they had reset the alarm or not, or they turned it off. A lot of confusion. And I went back upstairs once they said it was okay, guess what? It went off again. I walked down the fire stairs again. I couldn't move for like, it's just amazing. Walking down fire stairs, 28 stories, you think like, oh man, really? That's nothing compared to walking up. It hurt. It was amazing. Uh, it's like half the height of the Freedom Tower, right?
Right.
But it was just interesting to see that even though they had all these systems that presumably were all like, interlinked and so forth, even the guys like, and they probably have even had some training on the fire. Like, you think like they don't have training on the fire alarm system? Of course they have training on the fire alarm system, but there was really confusion about what was going on and what's next, and is this off or is it on? You know,
Hmm.
I was pretty shocked by that. That was very eye opening. I'm like, we're not even at the lighting portion yet, and there's so
Right.
much confusion. It's
Right.
like, wow, guys, you got a lot
Yep.
of work to do here. Get your act
Totally.
together. Yeah.
Totally. And I think that is also another roadblock for sure to point out
Hmm.
is how we are expected to behave during emergency conditions and how to properly
Yeah.
communicate those emergency conditions.
Yep.
And, I think we all can pull from our personal experiences and point to like a time when the fire alarm went off and nobody did anything. And so it's
Yeah.
like, yeah, there's still a lot to be done when it comes to this. But we're almost out of
Yeah.
time here. So I just want to
Hmm.
kind of summarize this. I mean, there's a lot of good stuff here. There's still way more to talk about. We'll probably have you back
Oh
on
yeah.
to continue doing a further deep dive. But basically, as it pertains to emergency lighting controls, the simplest important component is that we have lighting during emergency. And all
Hmm.
of the controls are meant to achieve that. It's not about anything more than just sufficient illumination for people to evacuate a building, or to maneuver around an emergency. And so as a result, the implementation right now is very simplistic. We're just basically transferring circuitry from the utility power to emergency power, or the internal components of the fixture do that already. Additionally, we need to make sure that controls are not overriding the lights to a condition that is unsafe. So whether they
Hmm.
are directly controlled, which means that they are actively receiving a signal during an emergency, or they just default to a state when they lose that signal. Those are the really important components of an emergency system right now and are what's required. How one achieves that is still kind of up in the air. There's definitely more hard facts on it, and it's evolving. But the standard that came out recently tried to clarify some confusion when it came to a specific part of the code requirements, and so as a result, hopefully there's less confusion, but definitely worth reading the article that you created, Steve. I think the majority of our industry, if not everybody, should at least give it a once over so that they can get a better understanding of emergency and especially the newer requirements. But I agree, where there should also be good courses and education materials out there other than this to help make people better at this, because it does become a challenge of who's responsible, who should do this, and it really is a team effort to achieve a quality emergency system, and it, because of the way lighting controls operate, it gets left to the last second, just like the whole system as it is for the most
Right.
part. And you don't want that to be the last thought. You don't want emergency to
Not
be
with
like,
this.
oh, right.
Right.
Yeah. No way. As Ron said before, yeah, no way. Not the last. So
Right.
the
Yeah.
LCA blog post that I finally was able to craft, which was really a collaboration with not only Rick but also all the whole LCA board. It was such a complicated topic, and because of the associated liability, that's why LCA said, hey, let's really go over this very carefully, which they
Hmm.
did,
Mm.
especially since I'm not a licensed electrical engineer anyway. So I'm really
Right.
grateful
Hmm.
that everybody participated in that. And it was really interesting because it showed me like, wow, there's a lot of new stuff here, and new equipment, new methodologies, and yeah, there's some differences of opinion about what this means. And so when you read the verbiage, there are things that I would take exception to right now, that if I were to speak in front of NFPA or UL, I'd be like, hey, you use the specific verbiage. It's not completely clear, right? But it's what it is. And Rick and I developed a 3-hour webinar about this that goes way beyond what you can glean out of the blog post that I wrote for LCA, because there's so much detail in it. And it's a little mind numbing and it might put you to sleep, but if you're concerned about the liability because you're dealing with this on a project under whatever role you're in, you may want to look at it. Yeah. Somebody has to do it. Whoever it is, somebody has to do it. Yeah.
Right.
Agreed. And you know what? Like, Steve, thank you for coming on. And that's a great spot, I think, for us to sort of let everyone take a breath. And if the last 45 minutes have made your brain explode, take a breath.
Yes.
It's not so bad. Everyone is here to help.
It's not.
We're here to help.
No,
You can
not,
reach
not
out
that
to
bad.
any of us. If you're a designer, reach out to your integrator, reach out to your EE. If you're an EE, talk to your designer, be part of the team. Everyone needs to work together to make sure that everything fits and works and plays nicely, and ultimately make sure that the system is designed correctly and safe and can get everyone in and out as necessary. So, Steve, thank you again for a great conversation. People's heads have probably exploded with all the information, but it's
Maybe.
okay. We're here to
Yeah.
help them digest it all.
Not that hard.
So I'll just take a minute to remind everybody, today's episode is presented by the LCA, the Lighting Controls Association, and it's also twice I did that. It's also financially supported by NAILD, the National Association of Innovative Lighting Distributors. And if you haven't checked out lightingcontrolspodcast.com yet, I don't know what you're waiting for. You can find everything you want there, our episodes, our merch. You can even find contacts for Webster and I. So when you go, I don't remember half of what I just learned, we're here to help you out. We've got your back. So thank you again for listening. And now to Webster to wrap us up.
And a special thanks to our sponsor, McWong Incorporated. You can find them at mcwonginc.com. So they used to have mcwonginc.info, but they also now have mcwonginc.com. Check them out. They have some great materials and resources. They support emergency lighting controls from various angles. You should check out their products. Really good resources. They're very helpful. They've got staff in this country ready to help you out. They've been in the business for more than 30 years. And additionally, congratulations to them for winning a Bright Star Award for innovation as it pertains to their True Blue Bluetooth mesh fixture controller with long range antenna. It's a really great resource for those projects that need that extra push on their extended range, but really an excellent platform to try and implement your lighting control solutions onto. And additionally, if you really love hearing these conversations and want to learn more about lighting controls, check out NYC Controlled. It's the conference coming up November 14th in New York. Check out the link that we have in our description. I will be speaking there, and maybe I'll run into you if you show up, but hopefully we'll see a good show of attendance for this. It's a brand new event that's definitely worth doing. But yeah, thank you everyone for joining us here today. And Steve, again, thank you. This was great. We're definitely going to have you back on to talk more about this in the future.